All right, here we go. Bubble sorts. I think if I write slow, the pen will behave. There's a dead spot on the screen over there. Okay, that's supposed to be an E. Sort. So I'm going to take the list. Let's take 3, 5, 7, 2, 4, 6. So this is the list of numbers that I want to sort. Now, I look at that list and I see 7's the biggest number. Now, my brain did a whole bunch of work really fast to see that. It did a quick comparison to all of the other numbers at once, right? A computer program can't do that all at once. It can only do it step by step. So how do we program a computer to do that? And there are many ways to sort. This is the idea of bubble sort. So what we're going to have to do is we're going to have to loop through the list where we just compare 2 numbers at a time. That's the best we can do with the computer. So the first time through the list, what the computer is going to do is going to compare those 2 numbers. We're going to do a sort to get the biggest things to the top. The computer is going to see, oh, 5 is bigger than 3, and it's going to want to do a swap. So it's going to switch the 5 and the 3. And that's all it's going to do the first time in. Because we can only do one thing at a time. When I looked at that 7 and sort as largest, again, my brain did a whole bunch of steps real fast. So I got to try and break it down. Now, again, we're going to loop through the list. So we just compared the first 2 positions. So now we need to compare the next 2 positions. So the computer looks, as is 7 bigger than 3? It is. So then we're going to do another flop. So it's going to switch the 7 and the 3. 5 is still up here. 2, 4, 6 is down there. And it's just going to keep moving to the next position in the list. So the next position in the list, I just started with 1 and then 2. Now I'm at position 3, 4. And it's going to say, is 2 bigger than 3? Answer is no. So it's just going to move on to the next spot in the list. So then it's going to go, is 4 bigger than 2? Yes. So it's going to do a swap. So this is the idea of bubble sort. We do 2 at a time, and if the one below is bigger, we just flip them. So we're going to switch the 4 and the 2. Otherwise, the 3, 7, and 5 stay where they were, and the 6 is still down here at the bottom. And then finally, we get down here. We're going to compare the 2 and the 6. The computer says, oh, 6 is bigger. So we're going to flop it. So we're going to do a switch there. It's going to put the 6 there and the 2 there. And then 4, 3, 7, 5 are still up above there. And I'm not going to go down to the last number for a comparison because there's nothing to compare underneath. So one thing to point out here is I don't need to run my loop the number of items in the list. It's 1 less because I'm comparing them in pairs. So I don't have to do 1 more check there. I've gone as far as I could. So that's my current run through the list. And again, this is a 5 right here. So then what we're going to do is we're going to start over. We're going to go back to the top of the list and see if we can do it again. So we're going to start off with the list 5, 7, 3, 4, 6, 2. And let's see, I'm running out of room there. Let's compress stuff a little bit. Move that up. And we're going to run through the list again. So the computer again looks at the first pair and it says, is the second one bigger? It's a yes. So it's going to reorder the list by switching the 7 and the 5. Oops, want a different color. And then it moves on to the next pair, 5 and 3, nothing to do there. So it looks at 3 and 4 and it says, ah, nice, I get to do a swap. So then we're going to have 7, 5, 4, 3, 6, 2. And it's going to look at the next pair, which would be these 2. And it's going to say, aha, we get to do another swap. So then we're going to switch the 6 and the 3. The 2 is down there. 4, 5, and 7 are above. And finally, it's going to look at the last pair, and there's nothing to do there. And then guess what's going to happen? It's going to go back to the top and check again. So I'm just going to put a little squiggly line there. So starting off with the list 7, 5, 4, 6, 3, 2, it's going to try again. It looks at that pair. 5 is smaller, nothing to do. 4 is smaller, nothing to do. Ah, 6 is finally bigger than the one above, and it's going to switch them out. 6, 4, oops, wrong color. 6, 4, we have the 5 and the 7 up there. We have the 3 and the 2 down here. And it's just going to keep looping through, right? So we have to have a loop that just keeps checking pairs, moving them as it finds them. So we check those two, nothing, those two, nothing. And we got to the bottom of the list, so we're done. And we do it again. So we have the list 7, 5, 6, 4, 3, 2. And we just keep comparing. Are those two in the right order? The answer is yeah, nothing to do. These two are not, so it's going to do a swap. So now we have 7, 6, 5, 4, 3, 2. And it's going to keep looking. So it's going to compare these two, nothing, those two, nothing, those two, nothing. Now, how is the computer going to know when it's done? Like you and I can look at that and think it's done because we recognize those numbers. But Scratch is not AI. It doesn't have that recognition. What's that?
You use a repeat until.
There's going to be a repeat until, yes. So finally we get to it and we see 7, 6, 5, 4, 3, 2. And the computer, our program is going to run through and look for swaps. Nope, 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 nope. There's no swaps. So that could be our signal for when it's done. Right? Every other time through this, we had at least one swap. Finally, we get to a pace where there's no more swaps when we do the comparison with the next number. And then we can finally say done at that point. So we need 2 loops to make this happen. One loop to make swaps with things that are adjacent to each other, and another loop to go back through and see if there's any more. And once we find there's no more swaps, it must be sorted, and we can finally say done. All right, so let's go see how the author of the book implemented this idea in a program. And there are other ways to do it. So I'll show you a slight modification on this in a minute. But let's take a look at the author's version. So here is the author's version of bubble sort. So they have a variable called done, and done is set to 0. And usually with computers, we have true false, which can also be equated to a 0 and a 1. So 0 is like false and 1 is like true. So setting done equal to 0 is like saying we're not done. Done is false. We're going to repeat so we have an outer loop, this repeat until, and it's going to repeat until done gets to stay as 1. Means true, we're done. And right away inside the loop, they say, oh, let's set done to 1. Okay. Now the outer loop doesn't know it yet because it happened inside, right? So the outer loop won't see done as 1 until all of this other code runs and we come back to the top to run again. So what happens in between? Well, we set position equal 1 so we can move through the list. Let's take a look at our list here. So here's my list. It's got 9 things in it right now. And let's see, they are currently in order. So I'm going to go shuffle those and put them out of order. And notice I pulled the bubble sort off and the shovel off that for now. So I can sort them. I can shuffle them separate from sorting it. And notice that the repeat repeats 1 less time than the length of the list, right? Because we're looking at adjacent pairs. And so there's 1 less adjacent pair than there are numbers in the list. And then inside it says, if the item in the position, let's say 1, is less than item in position, the next position over, then we're ready to do a swap because we have a smaller number on top. Okay, you could change the logic to be we have a bigger number underneath. You could go either way, less than or greater than. They chose a less than here. And then to do the swap, you need a temporary variable, like we did with the Fibonacci numbers. Remember those a while back? So what we do is we take the first item and we put that in temp for a minute. We then replace the first item with the next item, and then we take the next item and make it whatever the first item was. So we need 3 things to make that swap inside the computer happen. We've got to have a temp variable to make that happen. And then because a swap happened, it resets done to 0. So that means a swap happened, we're probably not done. And then it changes position by 1, and it goes back inside the inner repeat, and then it looks at the next pair. So this inner repeat right here is like in my notes. I just went through one of these right here. And the inner repeat's going to keep going until it does it this many times. Okay. Each time it does that, if it finds a swap, it puts done back at 0, so that when we finally go to the last pair and get to the outer repeat, done is still 0 because we just saw a swap and we're going to try again. And then it's going to keep doing that. Finally, at some point, like in my example, hang on a minute, Aiden. I did that 1, 2. So this is the inner loop there. Here's another run of the inner loop. Here's another run of the inner loop. It found swaps. It's going to run the inner loop one more time. And that last time it saw no swaps, which means in the code, it never got inside this if, which means done is stuck at 1. It jumps to the outer loop. Outer loop, the outer loop says, oh, done is finally 1. I can jump out. What's outside of the outer loop? The answer is nothing, so the procedure is done at that point. So that's what should happen when it runs this. Now, the cool thing about this particular setup, in that they have this shuffle script inside here, we can run this in basically different lists, because every time we shuffle, we're going to get a slightly different version of the list. Or we could make up, remember we made that random list generator the other day? We could put that code in here and make all kinds of new lists to see what happens. Questions on how the bubble sort works?
I'm just looking
kind
at the code
Looking
and
at that code. So that code is in your book.
what I did for shuffle.
Yep. Oh, you're doing your own shuffle?
Yeah,
Cool.
made it as few code as possible.
Cool. All right. So I'll take a look at that in just a minute. So I'm going to show you another version of bubble sorts, and then we'll talk about some things you need to figure out for the homework. So let's see. So I made a different version here, and I mentioned before that often when I write new code, I run into problems. Things don't work the way I hope they would. And sometimes what I do inside my code is I put some say blocks to tell me what the values of different variables are, different parts of a list, to help me troubleshoot what's going on. So when I was working on a slightly different version of the bubble sort, I put a say that I'm swapping this item with that item in the list, so I could see what was happening at every stage inside the loop. I don't need that to run the script, but it was helping me to make sure I had my stuff in order. Now, the thing I did that was a little bit different is instead of switching done on and off all the time, what I added was a variable called number swapped that counts how many swaps there were each time the inner loop runs. And the only time that I'm going to set done to true is if I found there were no swaps when I ran through. So slightly different way to kind of trigger what's going on there. So underneath my inner repeat loop, I have an if that just says, hey, if the number swapped happens to be 0 after running through that routine, then we'll say it's sorted and we're done. So I use the variable called sorted instead of done. So same idea. The swapping is a pretty standard thing. If you need to swap 2 things in a list, you got to have a temporary variable to do that with. Okay. The book used a variable called temp. I'm using a variable called swap. But otherwise, it's pretty similar. I just chose to flag when we were done a little bit different by counting how many repeats were in there each time. All right. What else do I have to say about this? I think that's about all